In this video, we'll look at how we name more complex branched alkanes, and we'll talk about naming cyclic alkanes. Okay, so for naming a branched chain alkane, if a substituent appears multiple times, we'll use a prefix. Our normal prefix is di, tri, tetra, etc., to say how many times it appears in the compound. So for example, in this one, if we find the parent branch, we can see that's this longest one here. And so substituents are two methyl groups. So this will be a dimethyl compound, and we'll minimize the location numbers on the parent molecule. So in this case, the parent molecule has 6 carbons, and so this will be dimethyl hexane. And for counting the positions, we have position 2 and position 4, so we'll write 2, 4 dimethyl hexane. Here we have one more example, so this will be a trimethyl hexane, but you'll notice in this case we can number from two directions. So if we number from this side, we have 1, 2, and if we number from the other side, we have 1, 2. So the first position is going to be 2 either direction. The difference is this next methyl group. If we keep going, it is 3 from this direction, and if we go from the other way, that would be 4. So what we do is we minimize the sum of location numbers. So in this case, the 3 is going to be the lower number in the total sum. So for naming this, we would do 2, 3, 5, trimethyl hexane. The sum of the 2, 3, and 5, that's going to add up to 10. If this was 4, that would have added up to 11. Okay, so now on with an even more complicated example. In this case, we have 3 substituents. 2 of them are still our normal methyl group, but the second one now has 2 carbons, so this would be a ethyl group. When we have 2 different substituents, we will list their names in alphabetical order, and this is going to exclude prefix. So we're not going to worry about the di for dimethyl. The methyl starts with an M, the ethyl starts with an E. So when we number these carbons, again, we want the smallest number possible, so we'll start on this end to get 1, 2, 3, 4, instead of starting from the other direction. We're going to name ethyl first, so this should be 4-ethyl, 2,3 dimethyl for the position, and then the parent group has 8 carbons, so dimethyl octane. So the whole name for this, 4-ethyl, 2,3 dimethyl octane. These can get even more complicated. The substituent itself can also have branching. There are a few cases where we'll use a common name for the branch substituent. So these are the common things that we see branched and the common names that we'll use instead of the normal systematic nomenclature. So if the parent chain is connected here, for these branching group of 3 carbons, this is isopropyl. If the parent chain is connected there for a branching group of 4, that is isobutyl. And we have a few other types of common butyl branching, the sec-butyl. So we can see in this case it's a 2 carbons attached and 1 carbon attached to where it's connected, whereas here it was 2 carbons both with a single one attached. And for tert-butyl, it's the 1 carbon with 3 different carbons attached to it. So, for example, if we wanted to name this compound, first we'd order our longest chain, so this is 7, so this is going to be a septane. Then we look at our functional groups. We have a methyl, and this one matches the tert-butyl, so it's 4 carbons, 1, 2, 3, 4, and this first carbon that it's attached to all has 1 carbon attached to it. And to put them alphabetically, we have one that starts with an M. And remember, we ignore prefixes, so one that starts with a B. So this would be 4-tert-butyl 2-methyl heptane. Okay, so with all of that practice, take a shot at naming this molecule. Right, and the correct answer for this is none of these. Let's count, first of all, to find our parent chain. So let's count a few different directions. So let's just start down here. This would be 1, 2, 3, 4, 5, 6. Let's try counting some other directions from that 3, 4, 5, 6. 6, 7, 8. So starting from here, we can get one that's 8 long. Let's check a few other ways for counting. And so one way to zero into on where we might be a longer chain is look at where the branches are. So in this case, right, here there's 2, here there's 3 branching off. So maybe if we started on this side, we could get a higher number. Let's try it. 1, 2, 3, 4, 5, 6. And again, we can look at the branches here. We have this chain on the bottom is longer than this one. So from 6, we get 7, 8, 9. So we can actually have a chain that's 9 long. So this one here is our parent chain. That's 9 carbons, so that's going to be a nonane. And now let's look at our substituents. So here we have a methyl group, and we have an ethyl group. And now we want to count for numbering. So again, we want the numbers to be as small as possible. If we look over here, we could get 1, 2, 3, 4. If we count from this direction, we get 1, 2, 3, 4. So we have a tie for the first position. We're going to favor the heavier chain, and this is what's coming first too, because of alphabetically it begins with an E. So this will be 4-ethyl, and that would make this 5,6-methyl. So for the full name, this would be a 4-ethyl 6-methyl nonane. Okay, so moving on, we'll talk about cyclic alkanes. These are actually going to be unsaturated, so this is our one unsaturated alkane. These are going to have fewer than 2n plus 2 hydrogens because the carbons are attached in a circle. So you can see in this case, right, we have 3 carbons. And so normally we would expect 6 plus 2, 8 hydrogens, but there's only 6 in this drawing. And that's because the hydrogens that would normally be at the end of a straight chain are replaced by this bond used to make it cyclic. And you can see that's going to be the case for all of these other cyclic alkanes. When we're naming them, we just put cyclo before the name of the alkane. So 3 carbons, that would be propane. So we're just going to call this cyclopropane. 4 carbons would be butane. So this is cyclobutane, and so on and so forth for cyclopentane and cyclohexane. We can also attach substituents to these cyclic molecules. If only one is present, we don't need to number because it would be the same no matter how we rotated it. So in this case, if we just have one ethyl group on the cyclohexane, it'll just be ethyl cyclohexane. If we have multiple substituents, we're going to use the same rules for numbering and naming as we do for branched alkanes. So we minimize the location numbers, and priority goes to the first alphabetical substituent. So in this case, we have an ethyl group and a methyl group. We're going to prioritize the ethyl since it comes first alphabetically. So this would be 1-ethyl, 2-methyl. And for the parent, that is 5 carbons. So the full name is 1-ethyl, 2-methyl cyclopentane. The parent molecule, whether there's a cyclic portion or not, is still always going to be the longest chain. So in this case, we have that pentane, which is 5. Or if we count the parent, we see that it has 7. So the parent molecule is going to be the heptane. Since the substituent is a cyclopentane, we will put it, as we do the other substituents, we will call this cyclopentyl heptane. In this case, since we could put this cyclopentyl group in many different locations, we do have to include the number, so this would be 1 cyclopentyl heptane.